this is 2.1 properties of exponents. So for properties of exponents, there is a multiplication property, a division property, a power property, product to a power, difference to a power, the zero power property. Then we'll talk about fractional exponents. Actually, I'm sorry, negative exponents. And then in the next section, we'll talk about fractional exponents and radicals. Okay, so you can make a little running list of all of the properties that we're learning. It'll be good to summarize them. The first one we start off with is multiplication. So first, what are we even talking about? In this section, we're talking about exponential expressions. An exponential expression is an expression where, what is this? An exponential expression is an expression where we have a number, or a variable, we call that our base, and it's being raised to a power or an exponent. Okay, we use exponents to represent repeated multiplication of a number. So something like x cubed, that's an exponential expression. That just means x times x times x. Or 2 to the third means 2 times 2 times 2. Okay, so our question is, what if we have a problem that has lots of exponential expressions being multiplied and divided and added, and how do we simplify those types of expressions? That's what these properties are going to tell us. Okay, the first property we have is the multiplication property. Ooh. The multiplication property tells us how to simplify expressions where two exponential terms with the same base are being multiplied. Okay, so if we have a to the m times a to the n, both of these are exponential expressions with a base of a. We can simplify this to one exponential expression by adding those exponents together. A to the m times a to the n equals a to the m plus n. All right, that's the multiplication property. For the multiplication property, we add our exponents. Don't multiply them, add the exponents. All right, problem 1 is worked out for us. You can read through the examples in problem 1 when you're doing your studying for this. I want to jump to the you try and the guided example problems. So I'll write the property again at the top so we can refer to it if we need to. It says if we take two exponential terms with the same base and they're being multiplied by each other, we can simplify this to one exponential term by keeping the base the same and adding the exponents together. All right, now we go. First group of problems. All right, first problem. Into the 4th power times into the 12th power. First, you have to check that the bases are the same. Here, these exponential expressions both have a base of n. That's good. If the bases are not the same, this property doesn't apply. But these are the same. So we're going to keep our base n, and then we're going to, I'm sorry, I want some color. I like that purple. All right, and then we're going to simplify this by adding the exponents. Into the 4th times into the 12th would be into the 4 plus 12, which is into the 16th power. And that's it. We'll leave the answer like this. For part B, we have b to the 6th times b to the 4th times another b. So we have 3 terms being multiplied here, but they all have the same base. So we'll just add up all 3 exponents. So this would be b to the 6 plus 4 plus 1, which is b to the 11th power. All right, for problem C. Now notice here, we don't just have exponential terms, we also have coefficients in front of those terms. When you have something like this, 4x to the 8th times 6x squared, we need to group together and multiply the like terms. That means we want to multiply all of the constants and multiply all of the terms of x. So we would have 4 times 6 times x to the 8th times x squared. 4 times 6 is 24. And then for the x to the 8th times x squared, we use the multiplication property, and this gives us x to the 8 plus 2. And finally, our answer will be 24 times x to the 10th power. All right, for problem E, we have 5 times 3z cubed x cubed minus 2z cubed x cubed. So again, we need to group together the like terms. All of these things are being multiplied. Multiplication is commutative, so we can switch the order here by just moving the terms around. Let's move the constants together. So we have 5 times -2. I'm sorry, I missed the 3. 5 times 3 times -2. And then move the z's together. We have z cubed times another z cubed, and then move the x's together. X cubed times x squared. All right. Now let's see what this gives us. So 5 times 3 times -2, that's -30. For the z's, z to the third times z to the third would be z to the 3 plus 3. And for the x's, we'll have x to the 3 plus 2. So our final answer here is -30, z to the 6th times x to the 5th. Notice we can't simplify this anymore. Like we can't add the 6 and a 5 together because those exponential terms have different bases. For part D, 3k to the 5th times k to the 4th would be 3 times k to the 5 plus 4, which is 3k to the 9th. For part F, this would be 4 times 3, and then times r to the 5th, times another r, and then times t. We multiply the 12 times 4, or 4 times 3, that's 12. R to the 5th times r would be r to the 5 plus 1, and then times t. So we should have 12 r to the 6th t. All right. For part G, we would have 9 times 3 times u squared times u cubed times v cubed times v to the 7th times t. So that's 27 u to the 2 plus 3, v to the 3 plus 7, and t. And then yes, this gives us 27 u to the 5th, v to the 10th times t. Last one, h. So this would be -3. -3 times 2 times x squared times x times y cubed times y to the 4th, which is -6 x cubed y to the 3 plus 4 is 7. Next property is the division property. The division property tells us how to simplify two exponential expressions with the same base that are being divided. And if when we multiply, we needed to add the exponents, when we divide, we should, you guessed it, subtract the exponents. A to the m divided by a to the n is a to the m minus n. Be careful here. You do need to start with the exponent of the numerator and then subtract the exponent of the denominator, m minus n. All right, so for the division property, we're subtracting exponents. The numerator exponent minus the denominator. X to the 20th over x to the 4th. This would be x to, that's not the right one. X to the 20 minus 4, which is x to the 16th power. For part B, when we have several different types of terms, like we have A terms and B terms and constants here, we can break this up just like we did in the last section of problems. So 4 over 6, we can simplify that. A to the 10th over A, we can simplify that. And then B to the 5th over B squared, we can simplify those separately. And then multiply our final answers together. For numerical expressions or fractions like this, 4 over 6, you want to simplify the fraction. 4 and 6 are both divisible by 2, so this is 2 over 3. Then for the A's, we have A to the 10th over A, that's A to the 10 minus 1. And for the B's, B to the 5th over B squared, that's B to the 5 minus 2. So this simplifies to 2 over 3, A to the 9th, B to the 3rd. You can write the answer this way, or you can write it all as one big fraction by writing 2a to the 9th, b to the 3rd, all over 3. Either way is correct. All right, on to problem C, 6 over 9. Sorry, 6x cubed y to the 8th over 9x y to the 5th. For the 6 over 9, let's try to simplify this. 6 over 9 would leave us with 2 in the numerator and 3 in the denominator. And then for the x's, we'll have x to the 3 minus 1 and y to the 8 minus 5. So this simplifies to 2x squared, y to the 3rd power, all over 3. All right, and then in the last problem, we have x's, y's, and w's. No constants out front that we have to worry about. So we'll just subtract the exponents for each variable. For the x's, we have x to the 20 minus 3. For the y's, we have y to the 7 minus 4. And for the w's, w to the 6 minus 4. That would simplify to x to the 17th power, y to the 3rd power, w squared. All right, this brings us to another very important property. Well, what if we had something like x to the 3rd over x to the 3rd? By this property, that would be x to the 3 minus 3, which is x to the 0. But what does it mean for us to have an expression or an exponent of 0? Well, we know that if we take anything and divide it by itself, x to the 3rd over x to the 3rd, that should be equal to 1. So putting these things together, using the division property, x to the 3rd over x to the 3rd is x to the 0. But then just using what we know about dividing something by itself, that should also be equal to 1. Then that means that these two terms should be equal. That's the 0 exponent property. If we have anything to the 0 power, that's equal to 1. So a to the 0 power equals 1. That's our third property. Okay, we're going to jump to problem 6, where we try to simplify exponential expressions using the 0 exponent property and then also the multiplication and division properties. Well, the division property here. Okay, so for problem 6, x to the 0 power times x to the 1. This would just be x to the, you can think of it as 0 plus 1, which is x to the 1 power, or we can just say that x to the 0 times x to the 1 is 1 times x to the 1, which is x. So both of these equal x, or x to the 1st power. For part B, we have 3 times x to the 0 power. So this would be 3 times 1, which is just 3. All right. For parts C, for C, D, E, and F, for all of these, we have, different terms, and we're going to have to match up our like terms. For part C, we have, let's just break it up, 12 over 4, and then times, we just have one x in the numerator, so times x, and then times y to the 5th over y to the 5th. Now, 12 over 4 is 3. And then we just have that x there, so times x. For the y to the 5th over y to the 5th, you can think of it 2 ways. If we already said this, if you divide something by itself, you get 1. So we know that's just going to be equal to 1. Or if you try to subtract the exponents, you get y to the 0 power, which is 1. Okay, so times 1, this just equals 3x. As we go through these properties and we start learning like multiple different types of properties, sometimes you'll run into situations where you can use more than one property to solve the problem. Both ways are valid. It's up to you to decide which way you want to go. All right, for part D, 9x to the 4th, y to the 5th, z to the 6th over 3, x, y to the 4th, z. So this would be 9 over 3 times x to the 4 minus 1 times y to the 5 minus 4 times z to the 6 minus 0, or you could just say it's times z to the 6th. Okay, that gives us 3x cubed y times z to the 6th. So x cubed y, z to the 6th. All right, two more. All right, pay close attention to part E here. In the numerator, we have x to the 5th times x squared times y to the 9th. In the denominator, we have x to the 7th times y to the 7th times y. So In the numerator, we can use the multiplication property for those two x terms. And in the denominator, we can use the multiplication property for those two y terms. Or you can try to first use the subtraction property to simplify and then use the other property. There are lots of ways that you can go about this. I am going to use the multiplication property first and then use the division property. So doing that. In the numerator, we have x to the 5 plus 2 times y to the 9th. And in the denominator, x to the 7th times y to the 7 plus 1. So what does that simplify to? X to the 7th, y to the 9th over x to the 7th, y to the 8th. The x to the 7th cancel each other out. And then y to the 9th over y to the 8th is y to the 9 minus 8, which is just y, or y to the first power. On to F. M, N, and P's here. So if we simplify the m's, we'll have m to the 3 minus 1. For the n's, n to the 5 minus 0. And for the p's, p to the 4 minus 1. This is m squared, n to the 5th, p to the 3rd power. That's our final answer. Next, we're going to go on to some problems where instead of having just one number in our base, we have more than one term being multiplied in the base. So this is the product to a power, a product to an exponent property. So if our base has one or more than one term being multiplied or divided, this only works when your base is being multiplied or divided, not added or subtracted. And then if your base is being raised to some exponent n, we can apply the exponent to each term in the base. So what does that mean? If we have a times b being raised to the nth power, that's just the same as a to the nth power times b to the nth power. So if we have a product raised to a power, it's the each term in the product raised to the power individually. Same if we have a difference raised to a power. Uh-oh, what am I doing? I don't like it with two lines. There we go, that's fine. All right, so if we have a over b to the n equals a to the n over, a over b to the n, we can apply the exponent n to each of the terms in the fractional exponent. That's a to the n over b to the n. All right, again, this only works when our base is being multiplied or divided, not when it's being added or subtracted. Please keep that in mind. All right, number 7 is an example that's already worked out for us, so we are skipping it. We're gonna go on to problem number 8, where we're gonna practice using the product to an exponent property and the quotient to an exponent property. So as you can see, all of these first 4 are products, but wait, there's more. If we go down, we'll see that there are some problems with the quotient to an exponent property as well. Also, as we're learning these, we may run into problems where we have to do more than one property in the problem. That's the fun ones. That's our goal. All right. For problem A, negative 8ab all being squared. We can apply that square to each term in the base. Please note that with that negative 8, I put that in parentheses because we're multiplying negative 8 times negative 8. So our answer should be a positive 64. And then times a squared times b squared. For problem B, 2x all raised to the 4th power. This would be 2 to the 4th power times x to the 4th power, which is 16x to the 4th. All right. For part C, be careful here. That 5 is outside of the parentheses, so that 5 is not being raised to the x power. Okay, what is this? Sorry. Things are popping up on my computer. So the 5 is not being raised to the x power, to the 3rd power. Only the a and b are. So this would just be 5 times a cubed, b cubed. And there's nothing else we can do to simplify that. Similarly, for part D, the 3x on the outside is not being squared. Only the x, y in parentheses is being squared. So this would be 3x then times x squared, y squared. But for this one, we can simplify a little bit more. For the two x's that we have there, we can combine them. 3 times x squared would give us 3 times x cubed times y squared. All right, I'll pause here really quickly for questions before we jump to the other 6 problems. Any questions about A through D here? All right. Then on to E through J. So for E, kind of works out the same as the last couple of problems. We'll have the -2m cubed, and then mn to the 4th is m to the 4th times n to the 4th. And we can combine the two m terms. So this becomes -2 m to the 7th n to the 4th. All right. Then for the last 5 problems, these all require us to use the quotient to a power property. I like letter F, we have numbers there. 1/4 cubed, this would be 1 cubed over 4 cubed, which is 1 over 64. Okay, for part G, 2x over 3, all raised to the 4th power. We're going to take each of those terms and raise them to the 4th power. So this would be 2 to the 4th power, x to the 4th power over 3 to the 4th power. For the numerical terms, we actually want to simplify those. 2 to the 4th power is 16. So we get 16x to the 4th. And then 3 to the 4th power is 81 over 81. All right. Ooh, look at H. So with H, we have -4 over w squared times -4 over w cubed. This is one of those problems where you actually have a little bit of choice. We could apply the square and the cube to each term in the base and then combine like terms and simplify afterwards. Or we can use the multiplication property first. Notice that both of these terms have the same base, -4 over w. So by the multiplication property, this should be equal to -4 over w to the 2 plus 3 power. So we can use the multiplication property first. Then that's -4 over w to the 5th power. Now we can use the quotient to a power rule. -4 to the 5th power over w to the 5th power. Oh, what's 4 to the 5th power? 64. Wait, 4 cubed is 64. That's, let's see. Oops, pressing all of the wrong buttons. I think it's 1,000. 4 to the 5th power would be 1,024. Let me double check myself. 1,024. All right, so this is 1,024 divided by w to the 5th. This is one way that we can solve this problem, or working a little bit backwards here. If you wanted to just apply the exponents of the bases first, you would have -4 squared over w squared times -4 cubed over w cubed, which would give us 16 over w squared times 64 over w squared cubed. 16 times 64 is 1,024, and w squared times w cubed is w to the 5th. You can do it either one of these ways. So this is just an example showing that sometimes there's more than one way to simplify the expressions. And both ways are valid. You can use either one. All right, knocking out the last couple problems here. 5p to the 3rd over q over p cubed. So we're gonna keep that 5p to the 3rd, and then we have times q cubed over p cubed. Now that p cubed on the outside and a p cubed in the denominator are gonna cancel out actually. But just to be clear so that we can all see that, we can write this as one big fraction where we multiply 5, well, think about the 5p cubed as a 5 over 1. So we have 5p cubed, q cubed over p cubed. Those p cubes cancel each other out. So we're just left with 5q cubed. All right, let's do the last one. 8xy cubed times 2x over y squared. So the 8 stays the same. For the xy, those are being raised to the third power. So we have x to the third, y to the third, and then times 2 squared, x squared over y squared. All right. First, couple things we can do here. The 2 squared is a 4. So this is 8x cubed, y cubed times 4x squared. And then we can write this all over y squared. Combining some of the like terms. We can combine the 8 times 4. And then for the x's, we have x cubed times x squared. And then for the y's, we have y cubed over y squared. All right, so that's 32 x to the 5th y, because 3 minus 2 is just 1. So we're just left with 1y. All right. What time is it? All right, we're making good time here. Any questions so far? All right, now I want us to be very careful with this next property. Okay. So for the next property, it's what happens if we have one exponential expression, but it's raised to a power and then raised to another power. So one base, two exponents. This is called the exponent to an exponent property. And we simplify this by multiplying your two exponents together. The reason why I say I want us to be careful with this one and not to mix it up with anything is we're multiplying the exponents, but this is not the multiplication property, okay? We use this property when we have one base, two exponents. We multiply the two exponents together to simplify. Problem number 10, let's go with the first one. X to the third to the 5th power, that would be x to the 3 times 5, which is x to the 15th power. And just to be clear, note the difference between x to the third times x to the 5th versus x to the third to the 5th power. The top one, we use a multiplication property and we add the exponents. X to the 3 plus 5, that equals x to the 8th. Like I said, for the last one, this is x to the 3 times 5, which is x to the 15th. Don't mix these two up. All right, for part B, we're going to apply the 5th power to each term in the base. So we have 3 to the 5th times v to the 6th to the 5th power. 3 to the 5th power is, that's 81 times 3, 243. Let me make sure I believe me again. All right, 81 times 3 is 243. Yes. So this would be 243, and then times v to the 6 times 5. So that's 243, v to the 30th power. All right, so we're combining a few properties together here. For part C, negative 4w cubed, all cubed, that's negative 4 cubed times w cubed cubed. That would give us negative 64 times w to the 3 times 3, which is negative 64, w to the 9th power. All right. Any questions about A, B, or C so far? Then let's keep rolling. For part D, we have -2, c squared, d to the 12th, all to the 7th power. So we're going to have to raise each of those terms to the 7th power. -2 to the 7th power times c squared to the 7th power times d to the 12th to the 7th power. All right, -2 to the 7th power is -2 to the 6 is 64. So this should be 120. What's 64 times 2? 128. 2 to the 7th. It'll be -128. Okay, so we'll have a -128, and then c to the 2 times 7, d to the 12 times 7. All right, 2 times 7 is 14. So this is c to the 14th power, and then d would be to the 12 times 7 is 84, 84th power. -128, c to the 14th, d to the 84th. So for E, so this would be first 2 cubed, u cubed, 5 squared, u to the 7th squared. So that would be 8 u to the 3rd times 125, u to the 14th. Oh, that's a square and not a cube. I'm sorry. I cubed it instead of squared it. So that's just 25. And then u to the 14th. Then this would be, what's 8 times 25? 200.
Yeah.
U to the 3rd. U to the 3rd plus u to the 14th is u to the 17th. Okay, whew. All right. 200 u to the 17th. Let me make sure I believe me. I had a typo there. 2 to the 3rd is 8. 5 squared is 25. 8 times 25 is 200. Then we have a u cubed and u to the 14th, which gives us u to the 17th. All right, I believe that one. All right, for F, this would be -1 to the 12th power over y cubed to the 12th power. So is -1 to the 12th power 1 or -1? We're looking at -1 raised to different powers. If the exponent is even, we get +1. If the exponent is odd, we get -1. So this would be a +1 over y to the 36th power. For part G, p cubed over q all to the 4th, that's p to the 3rd to the 4th over q to the 4th, which would be p to the 12th over q to the 4th. Someone just shared their answer for this one too. And we'll stop there for that. And then for H, 9y times y cubed to the 5th over x to the 5th. This gives us 9y times y to the 15th over x to the 5th. And then if we put it all together, we get 9y to the 16th over x to the 5th power. Sorry, my 16 looked weird. All right. S3, -2x times x squared to the 3rd. This would be -2x times x to the 6th, which is -2x to the 7th. That one's not so bad. Part J, we have -4x squared times x cubed to the 4th. That's -4x squared times x to the 12th, which would be -4x to the 14th power. And then the last two. All right, we have a lot going on here. You have some zeros, some multiplication, some dividing, all kinds of stuff. All right, for the first part, 4a to the 0 b squared. A to the 0 is just 1, so this is 4b squared, and then times 2 squared times a to the 6th power, because we have a cubed squared, and then b to the 8th power, all divided by b squared. All right, and of course we can write this all under one over, or all as one fraction. And then there are a couple ways you can do it. The most obvious thing that I would do is cancel out those two b squareds. And then what's left? 4 times 2 squared would be 4 times 4, which is 16. And then we have an a to the 6th and a b to the 8th. All right, then on to problem L. 3m to the fourth squared times m cubed into the fifth over 2 all cubed. All right, so we'll have 3 squared, m to the fourth squared times m cubed into the fifth cubed over 2 cubed. All right, let's put it all together. We get a 9 m to the eighth, and then times another m to the ninth, and then n to the 15th. And it'll all be over 2 cubed, 8. Then the last thing that we can simplify here is we can combine the m terms. This will give us 9 m to the 17th power into the 15th power over 8. Our next property, which deals with negative exponents. So what does it mean if we have a negative exponent? Okay, saying that we have a to the negative mth power is equivalent to 1 over a to the m. No, what happened? All right, there we go. A to the negative m is 1 over a to the m. So if we have a negative exponent, we can flip this and make it a fraction and move our exponential term down to the denominator and the exponent becomes positive. We also may have a situation where we have a negative exponent in our denominator already. Having a negative exponent in your denominator, like 1 over a to the negative m, we can flip that negative term to the numerator and just make that a to the positive m power. And also, if we have a fractional exponent, a over b, a fractional base, a over b to a negative exponent, negative to the negative mth power, that would flip our base. That's b over a to the positive mth power. Okay, and then last one. All right, so we're gonna use all of these properties along with our previous properties to try to simplify lots and lots of examples. All right, this is mixed properties of exponents. So all of the properties that we've gone over today, all put into one group of problems. The first one, 7 times a to the 0, that's 7 times 1, which is 7. All right, the next example, 7 times a to the negative third power. With a negative exponent, we can rewrite this as 7 over a to the positive third power. I didn't read our directions, but for our final answers, we want our answers to have positive exponents only. All right, for 5a to the negative second over 3. That's 5 over 3, and we're going to move that a term with the negative exponent down to the denominator and make the exponent positive. So 5 over 3a squared. For part D here, we start off with a negative exponent in our denominator, 7 over x to the negative second power. So the negative exponent in the denominator tells us we can move that x term up to the numerator. So this would just be 7 times x squared. All right. I'll pause really quickly on the first 4. Any questions so far? Remember, with negative exponents, we move the term from the numerator to the denominator or denominator to numerator and make the exponent positive. All right, for part E, 7a to the negative first power, this would be 1 over 7a to the positive first power, but the first power is just 1, so 1 over 7a. And then, part F is a good one. When we have a fractional base to a negative exponent, the negative exponent tells us to flip or take the reciprocal of our base. So 7 over a to the negative first power would be a over 7 to the positive first power, or just a over 7. All right. Let's keep on going. For problems G and H, we're going to be using the multiplication property, but some of our exponents are negative. So with negative exponents. Here for G, we have 3 times, well, let's multiply all of the constants, 2 times 3, and then times u to the negative second times u squared, and v to the negative second times v squared. When we simplify this, 3 times 2 times 3 is 18. And then for the u's, we have u to the negative 2 plus 2, and similarly for the v's, negative 2 plus 2. Negative 2 plus 2 is 0. So that's 18, u to the 0, v to the 0. That just is 18. The u's and the v's cancel out. All right, where are we? Need more space over here for part H. For part H, we'll group together our like terms again. So 7 times 5 times a squared times a times b to the negative second. This would be 35, and then a squared times a is a cubed. And we want our exponents to be positive, so we'll move that b to the negative second power down to the denominator. So divide by b squared. For problem, where are we? I, x to the 5th over x to the negative 3rd, all to the 4th power. X to the 5th to the 4th over, x to the 5th, y to the negative 3rd, all to the 4th. Y to the negative 3rd to the 4th. That's x to the 20th power over y to the negative 12th, which is x to the 20th. We can move that y term up to the numerator, times y to the 12th power. All right. Ooh, what's going on in part J? So in part J, we have AB over A cubed, B cubed, all raised to the negative second power. You could apply everything to the negative second power to everything, but I'm going to first get rid of the negative by flipping my base. So this would be the same as A cubed B squared over AB, all to the positive second power. And then we can apply the square to each term in the base. That would give us A cubed squared times B squared squared over A squared B squared. That would be A to the 6th, B to the 4th over A squared B squared. Then using the division property, we have A to the 6 minus 2, B to the 4 minus 2. Actually, this is not wrong, but there's a more efficient way to do this. All right, we're almost done, so let's just write it out. A to the 4th B squared. All right, didn't make any incorrect steps. The answer is correct, but a better way to do this problem would be to, before you apply the square to each term in the base, simplify your base first, if it's possible to simplify. So what do I mean by that? I could have started off this problem by simplifying, or from the A cubed B squared over AB squared. I could have started off this problem by simplifying the A cubed over A. This would just be A squared, and then the B squared over B, all to the second power. And then that makes this a little bit easier, because now we only have to do A squared squared times B squared, which is A to the 4th B squared. Of course, we get the same answer, but this method, we can do it with fewer steps. All right, then for K, 15p to the 7th over 3p to the negative 4th. You can do this 2 different ways. You can use the division property, or you can move the p up and then use the multiplication property. I'll just go straight to division. This is 5p to the 7 minus negative 4. So that's 5p to the 11th power. And then for part L, we have 5n to the 4th times 1 over negative 3n cubed, all squared. That's the first step. Second step, let's apply the square to every term in the base there. So this would be 1 over -3 squared n cubed squared. And if I just combine these into one fraction, that's 5n squared over 9 into the 6th. Ooh, I don't know why I made that n squared. It's supposed to be an n to the 4th. I just changed it to a 2 for no reason. So 5 into the 4th, that's right, over 9n squared, or into the 6th. All right, from here, we can simplify the n's into the 4 over into the 6th. This leaves us with 5 over 9 into the -2nd power, or we can just move that 2 back down. So when you have something like this, so it's 5 over 9 n squared would be our final answer. -10 p to the -8th over p squared. You can move the p to the 8th down. So you can write this as -10 over p squared times p to the 8th. And then that would be -10 over p to the 10th. Or you could have done this as -10 p to the -8 minus 2, which is -10 p to the -10, which still gets you, of course, the same answer. -10 over p to the 10th. All right, for n, we have x's, y's, and w's. Let's try to simplify them all. For the x's, I'm just going to use the division property. We have x to the 2 minus -5, y to the -3 minus 3, and then w to the -4, minus 0, but that term's just going to go away. So we end up with x to the 7th, y to the -6th, w to the -4th. All right, for our final answer, since we want only positive exponents, we're going to move the terms with negative exponents down to the denominator. So this would give us x to the 7th over y to the 6th, w to the 4th. All right, and for part O, this problem looks worse than it is, I think. I mean, it is a little bad, but it's not as bad as it looks. We're going to start off the problem by trying to simplify what's in the parentheses before we apply exponents or group together terms or anything else. For the first set of exponents, we have 15 over 3, that's 5. And then x to the 4th over x to the -3rd. That would be x to the 4 minus -3, which is x to the 7th. And then y cubed. Okay, that's the first part. For this second set of parentheses, 24 over 8 is 3. And then we have x to the 3rd over x squared. That just leaves us with an x. And then for the y's, we have y squared in the numerator, but y to the 4th in the denominator. So we're going to end up with a y squared in our denominator. And that's being raised to the -3rd power. I should move all of this. No, we're going to need all this room. Okay. From here, now we want to take care of the term with the -3rd power. We can flip the base. So we have 5x to the 7th y cubed times y squared over 3x cubed, and then apply the cube to every term in the base for the second expression. 5x to the 7th y cubed, and this would be times y squared cubed would be y to the 6th. 3 cubed is 27 and x cubed. All right. Believe me so far. Like I said, we needed more space, so I'll move up here now. Now we can just combine everything and look at the like terms. So our constants are, we have 5 over 27, nothing's happening with that. And then we have x to the 7th, y cubed, y to the 6th over x cubed. All right, so for the x's, we have to use, did I miss a y? No. For the x's, we have to use the division property. For the y's, we have to use the multiplication property. This will leave us with 5. X to the 7 minus 3 is 4. And then y to the 3 plus 6, which is 9. over, we still have that 27 down there, 27. All right, whew. Last one. Again, we want to start off by trying to simplify what's in the parentheses. We can go ahead and distribute the 2 in the first term. This would be x to the 8th, y to the 4th. Let's just let that sit there. Then over here, what's going on? Y to the negative second over y to the, I'm sorry, x to the negative second over x to the negative third, y over y to the negative third. That simplifies to x to the negative 2 minus 3, y to the 1 minus, minus negative 3. I want to be clear about how this is simplifying because there's a lot of negatives. It can be a little tricky. So the x's, x to the negative 2 minus negative 3, y to the 1 minus negative 3. And then this is all raised to the negative second power, x to the 8th, y to the 4th. This would give us x to the first power, negative 2 plus 3 is 1, and y to the 4th power, all to the negative second power. Okay, so this gives us x to the 8th, y to the 4th, and then x to the negative 2, y to the negative 8. There's a couple different things you can do. You can move the negative terms to the denominator. You can go straight to using the multiplication property to simplify the x's and the y's, and then move the stuff to the denominator. It's really up to you. Since I think previously we moved it to the denominator, let's just try to rearrange the terms here. X to the 8th times x to the negative second power times y to the 4th, y to the negative 8th power. This gives us x to the positive 6th, y to the negative 4th, and our final answer would be x to the 6th over y to the 4th power. Again, there's a few different ways you could have gone about simplifying there in the middle, and you might have gotten a different answer. Last problem in this section is just practicing using the negative exponent property a little bit more and rewriting some terms. So for problem 14, problem 14, where's my T? For problem 14, we are going to rewrite these with positive exponents only. X to the negative third power would be 1 over x to the third. That's all we have to do. 1 over x to the negative third power would be x to the third power. 2 to the negative third power would be 1 over 2 to the third, which is 1 over 8. We have a fraction with a negative exponent. Remember, we flipped the base. So 4/5 squared would be 5/4. 4/5 to the negative second, is 5/4 squared, which is 5 squared over 4 squared, or 25 over 16. All right, 2 more problems. 3x to the negative 4th. Only the x is being raised to the negative 4th, so the 3 stays where it is, and the x to the 4th moves to the denominator. And last one, 3x all raised to the negative 4th. Both the 3 and the x are being raised to the negative 4th power here. So this would be 1 over 3x to the 4th power, which is 1 over 3 to the 4th power, x to the 4th power, which is 1 over 81, x to the 4th power.